did it, the Prevnar hypothesis test wrap up. If you didn't do it, that's totally fine. We'll do it together. I got no problem with that. Make sure this is working. Good. TI's working. We're good. So, we were analyzing Prevnar, the side effect of Prevnar. Trying to see if Prevnar creates loss of appetite. Did we have a hypothesis? I think we did, didn't we? Do we have a hypothesis to check? So we're trying to see, this is the Prevnar one. Prevnar. Because one thing, we were testing little p, which was, I think it was the rate of appetite loss in infants, is that right?
The proportion of infants experiencing appetite loss.
Cool.
After receiving the...
Awesome. The rate of appetite loss of using Prevnar, right?
Yeah.
Cool. What Chris just said is perfect. And we're trying to compare it to the general population, which I didn't print on your data sheet, but we gave it to you in a second, after we established this. So variables little p, because we're looking at a rate. The hypotheses were what? Start with little p's. What was our research hypothesis? I like going with that one.
It's greater than 1.
Yes, ma'am.
135.
Yes. Is Prevnar's loss of appetite rate greater than 13.5%, which is what it would be on competing medications? So maybe Prevnar works great for spinal meningitis, but if the kids then aren't going to eat, that doesn't help us very much. We have to fix that, potentially. Or is it just higher? Why do we pick higher? Excuse me, Squeaky. Why do we pick higher? Was that a random guess?
We wanted to know if it increased the...
Good, but why would we even think that, based on the data?
It says that it shows how it is.
Higher.
Because p hat in the sample was higher, wasn't it? Wasn't that around 17% if I remember correctly? Yeah, that was what triggered us, like, oh boy. We got the appetite suppressant, or the appetite loss rate in at 17%, like, that is higher than 13.5. But all the votes haven't been counted yet, right? All the votes haven't been counted, which means we got to stop a margin of error on that, which means we're not done with the test yet. Is that fair? Is that good? Is that fair? Believable? Good. Good. So the null is either this. A lot of times, friends, you're going to see an equal sign and only an equal sign. I don't like that as much mathematically. I like them being opposites of each other. But a lot of times in research, they'll just drop an equal sign, which is totally fine. Good so far? Happy so far? Content so far? Okay, so essentially, here's what we need to know. Here, I'm going to draw a bell to get us the picture that we need to address. We've got appetite loss in the general population. We've also got appetite loss on Prevnar. We're going to assume that they're the same for starters. So we've got this appetite loss. That's 13.5%. We've got that. Got another color. We've got this appetite loss. That's 13.5%. Our sample just came in. It's definitely higher at 17%. Now, we're going to call 13.5 0 to normalize it. And I say we are going to do this. The technology is going to do it for us. But that's what we're going to do. We're normalizing these all back to the same bell curve. The question we now have is, how far up is that, right? How far up is Prevnar's rate of 17%? Suppose it comes out being 0.5. Suppose the actual z value here, right? That's a z-score, correct? That's a z-score. Suppose it comes out being 0.5. 0.5. Not 50%, just the z-score itself is 0.5. Would we be nervous about Prevnar then?
Retest.
No, we got, hang on. We got a retest and we got a no. I like these answers. I can accept either of them for different reasons. Brandon, why no?
Because it's not statistically significant. It's not that far away.
Because it's not. This is one great answer. If the z-score comes in at 0.5, I've actually drawn it too far to the right. It would be more like down here if it came in at 0.5. So Brandon's conclusion would be, that means that the Prevnar curve, although it might be to the right, is not significantly to the right. I love that answer. Does everybody follow that argument? So that's based on if the z-score is pretty small compared to 0. We know it can't be negative, right? We know the z-score can't be negative based on our data. How come? Tell me.
It's bigger.
Because p hat's bigger than little p. It's already, the sample is to the right of the population's assumed value. So we know it's going to be positive. The question is how positive. So Brandon's answer is a fantastic one. Here's why Elizabeth's is also. She said retest. If Elizabeth dearly wants to avoid what kind of error, you might have to retest. Now let's before we answer your question directly, let's go down to the next parts of the template sheet, okay? Before we directly answer your question, Elizabeth, because I love both of your answers, but it depends on how you're going to look at numbers 4 and 5 before we decide. So question number 4 is define the 2 types of error, okay, in context. So what would a type 1 be in this case? You can't make both kinds of, you can only make one of the 2 types of error depending on your results. So a type 1, a false positive, give it to me in words.
We say it's causing appetite loss and it's not.
We say it's causing appetite loss, but it's not causing appetite loss. That's a type 1. Can you see why that's a type 1, why that's a false positive? We're saying something has changed. We're saying Prevnar is making kids not eat. But it actually is making kids not eat. This is my student emailing me from Spain. Playlist is broken! Playlist is broken! Thinking of a different one. Sky is falling! Sky is falling! Chicken Little? It's a Chicken Little, right? The sky is falling. Type 1 error. Maybe it's not. Maybe you're walking at Smith Rock and the rock just tumbled off the cliff, as often happens. Rare. If we don't have sky fall. Fair enough? Okay, good. So that's a type 1. What would a type 2 be? Oh, time out, time out. In order to make a type 1 error, how big would your p-value have to be? I'm getting ahead of ourselves a little bit here. In order to make a type 1 error, in other words, in order to make a false positive result, how big of a p-value would you have to have? Big or small? Let's answer it that way. Big or small?
Small.
Vote for small. Vote second for small from Anna, thank you. Yeah, it has to be, right? Why?
To push you into that 5% region.
In order for it to be a false positive, the kick is that it's positive. In order to have a positive test result, you must be far away from the hypothesized mean. So you have to be pretty far away from 0, which would make a very small p-value, wouldn't it? Would make a very small p-value. You have to be far away to have a small p-value. And that's what makes a positive test result. Whether it's true or false, you get a small p-value for either of those. So we don't know that yet. We don't even know, we don't know what our p-value, we haven't calculated it yet, have we? We're getting there, we're getting there. Type 2 error! Give it to me!
You say it doesn't cause appetite loss, but it does.
You come back and say, you know what, Prevnar's great, it fights meningitis and the kid's eating like a pig. But unfortunately, on average, you got an outlier, and the kids actually aren't, they are suffering more appetite loss. You just missed it. You just missed it. That'd be a type 2 error, false negative. We'd have to get a big p-value for that one, wouldn't we? Good, 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 good. So those are the 2 types of errors, false positives and false negatives in context. Thank you, guys. Which one would you rather avoid?
2.
Oh! The front row votes for type 2, type 2, type 2, type 2. David says type 2 as well. I want to avoid type 2. Tell me why, you guys.
We don't want the kids to have appetite loss and us not know.
We don't want a side effect to sneak through, right? Especially if you're making drugs in a litigious society like probably if this is going to America. You don't want that kind of stuff to slip through. You want to control for that really, 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 really carefully. Does that make sense? Now, I know I've been talking about this a lot without mathematical justification yet. The Power Project is coming, which will justify this mathematically. But if you want to deathly avoid a type 2 error, what do you have to do to the confidence of your test? Do you remember? It's okay if you don't. It's been a long week.
Lower it?
You have to lower it. Yes, ma'am. You have to lower your confidence in order to reduce a type 2 error. Because if you know, in order to reduce a type 2 error, you have to increase the chance of a type 1, and that means lowering confidence. That essentially means taking this line and sliding it back so that's more than 5%. Remember, when you want to avoid a type 2 error, there's a curve up here you're not seeing. It's the other curve. It's the alternate bell curve. The position of that alternate bell curve. This is dealing with a type 1 error, this area out here. The type 2 error is the other curve that your fourth project is going to deal with, that other curve. So that's why I said I liked Elizabeth's answer. And especially hearing that you want to avoid a type 2 error. Because if you want to avoid a type 2 error, that 0.5, that z-score, might actually put it into that reduced confidence region, which would mean retesting, wouldn't it? Maybe. That depends on how low your confidence is and how far over the z is. But that's why I like both your errors. It all depends on what kind of error you want to avoid. Cool? Questions for you not to have answers for right now. Questions for you to take forward into your research. Fair? 247 kind of stuff. 248. Making up new classes here. Fair? Good? All right. Anybody say type 1's worse? There's no right or wrong answer for these questions, by the way. It's all what you think, in your personal opinion, which one is worse. We're pretty much your favorite type 2s? Cool. Awesome. I'm with you on that one, too. I think for things like medicine, you want to avoid type 2s because you don't want to inadvertently put something out that could damage somebody. Good. All right. Which distribution are we going to be using? Z. Proportions, yes? So now, we knew that already because I kind of gave you the answer because sometimes I forget where we're going. So now the question is, what is that number right there? And then paired with that in number 8 is what is that area right there. This is your p-value, yes? That's your p-value. What number is here and what p-value is there. This is where we lean on technology pretty heavily here. Because, I mean, we already calculated the flu vaccine by hand. It seemed like you guys didn't care for that too much. Good for you. I don't care for it either. I mean, it's fun seeing how it works.